In this tutorial today, I'm going to show you how I made this force field particle effect in TouchDesigner. All right, let's get started. So I'm going to create my variables first here, starting with a constant that I'm going to call res. Let's do 60. This will be my the size of my width and height of my texture for my particles. Let's put that into a null, call it variables. Let's right click, hit view, and put that up top, so I can get it wherever I'm at. Okay, let's also add some more things. I'm gonna add a merge because I also want to make a particle count. So let's put this into a function and do the input to the exponent and rename that to particles. It's gonna be my particle count. Okay, the other thing I want to do is add a reset with a keyboard in, oops, not keyframe, keyboard. Let's rename that to reset, put that into a merge. I also want to do a count of that, rename that. I'm going to call that seed because this is going to be for my seed value for all my noise tops. And let's test it, great. Okay, so to simplify that, I'm going to select all the middle stuff, collapse it in, because this is the only one I'm really going to be changing from the outside. Okay, so now let's get started with our particle textures. So we'll start with a noise and set the resolution with this variable. Let's set our seed with this. Let's make it not monochrome. I want it to be a 32-bit RG because this is going to be our XY positions for our particles. We'll set them to random, and let's go nearest pixel on both of those. Great. So let's add that to a null and call this start position. Okay, this is where my particles are all going to start, and they'll change every time I hit one. So let's put that into a feedback loop. And then that feedback loop is going to go into my calculation, then out to another null called toPositionFeedback. Okay, so let's collapse this. And inside of this base is where I'm going to do all my calculation of what the forces are between each particle. So let's do force calculation. And yeah, okay, so let's get in there. So spread these out a little bit and delete my middle one, disconnect my connection here. And let's make our instancing network. So just a basic instancing network here to start. So start with a circle. I'm gonna put that around 0.04 for the radius. And then bring it into a geometry. Add a camera, add a material, and add a render. Okay, for the camera, I want the view to be orthographic, bottom left and 1. That means my camera view is going to be 1 by 1 by 1, as long as I make this a square, which I want to do for right now to render the entire set of particles. So 1920 by 1920 square is what I'm going to do for that right now. Okay, and then I'm going to set up my instancing in my geometry, turn instancing on, and let's make a null for this just to keep things nice and separated and clean here. So I'm going to call this position, and in my instancing, I'm going to drag that into the translate R and G. Okay, so now I've got all my circles spread out here and showing. So the next thing I want to do, and kind of the most complicated part, is I'm going to turn this texture from a white texture into a force field texture. So what does that mean? Let's just make it, and then I'll explain it in the process. So I'm going to start out with a constant. This is mostly just going to get used to reference the size in case I want to change it later on. And there's going to be 3 textures I'm going to make from this to build my force, 3 main textures at least. So the first one's going to be a ramp that I'm only going to use that input as the resolution. This ramp is going to be a circular ramp, and I want it to hold. I also want it to be white in the middle and black on the outside. And also I want this to be 32-bit mono. Okay, that's the first ramp. The second ramp is going to be to create my red values. So I want this also to be circular. Oh, sorry, not circular. I actually want it to be radial. And in this, I also wanted to do a mirror. And then I'm going to make my period 0.5. And I'm going to go into this DAT file that actually controls my ramp data, just to make sure I'm nice and precise on this. So I know I want to go from 0 to 1. And I only want this to be half of it, actually. So period, I want to be, how do I do this again? Oh, I know what I want to do. So I don't want to go from red 0 to 1. I want to go from red -1 to 1. That's what I want. Great. Okay. I want to do a very similar thing with my green ramp. So I'm going to copy and paste it. And instead of -1 to 1, I'm going to do that in the green column. And then for the phase of this, I want it to be off phase by 50%. Okay, and the way this is working, so I'm building up here a texture that I'm going to be sampling to get a value of which way I want to push from that particle. So right now, a positive red value is to the right and a negative red value is to the left. So right now, this will be pushing everything to the right from this side and to the left from this side. I actually want that to be the opposite, and the way I can change that is just flipping the phase around. I'm going to do that for both of these actually by adding 1 to the phase. So now this means my green values will get pushed down, my red values will get pushed left from there at least, although since I'm going from -1, oh, I need to set this, so let's do 32 RG for this, just so when they come together, well, so we can see both of them actually. So yeah, so we see here, if we go in and sample this data, so we have positive numbers on the right, negative numbers on the left. We can see this value here. And then the same for my green values. So negative on the bottom, positive on the top. Great. Okay, so let's combine all these together. Let's do a reorder. So I want to bring in my red values from input 1, my green values from input 2. Let's set this to 32 RG. And then I want to multiply this by my my mono ramp that I've got here. So let's multiply it by that. Make sure this one is 32-bit RG. All right, so let's investigate this a little bit just so we can see what's happening here. I'm going to use a top to chop to kind of visualize what these values are doing and how we're going to use them here in the future. So right now, so when I combine these two sort of force textures, I get this, -1 on the left side, +1 on the right side, but it's the same. So as soon as if a particle starts sampling from here, it's going to immediately go from 0 to 1 and push in that direction. But that's not what I want. I want it to be a little smoother. So I've got this ramp that's ramping things up based on the distance from the center. So adding this multiply makes it so that it slowly adds in, slowly adds out. And another thing I like to do here is if I add a level after my initial ramp, I can play with the gamma to make this a little more of an exponential curve. So that way I have a more pronounced effect from, a much subtler effect from farther away and much stronger effect closer. So I get this sort of exponential curve, this distance curve, that's a little more natural feeling. Okay, let's bring this out to a null. And then we'll call this force field. And yeah, let's bring that onto our constant. Okay, so now I've got this nice spread out set of force fields, but I need to make it so they overlap in a nice way. So let's go into our constant. Let's change our alpha value based on the number of particles. So I could say 1 over the number of particles to calculate this. That's a bit overkill because there's very little chance all of these are going to be overlapping all at once, and I need to calculate every single one possibly that overlapping each other. So let's divide that by like 4 just to it'll give me a little more, or sorry, let's make sure we put this in the parentheses. So So that way, you know, I still get a good amount of transparency, but I don't lose all my precision from with the really small numbers being calculated here. Okay, so let's fix our errors here. We've got a transparency error. That means in our material, I need to go into the common value, turn on blending. I'm going to turn off the depth test. Let's look at our hit A and N on the render just so we can see what's happening here. So, okay, we're getting something. Okay, this reminds me I also need to turn off dithering. Okay, another thing I need to do here, I need to make this 32-bit float. Right, okay, that's what I needed to do. So I'm gonna make this 32-bit, I'm gonna make it actually 30-bit RG because I only care about the red and green values here. And let's go ahead and take that out of this. Yeah, okay, we'll leave that there for now. Come back and do some more for this later. Okay, so now I've got my force values, but this is the force across my entire simulation. I want to actually, I want this feedback loop to be adding this force to my position data. So I need to do a remap. So let's add our remap. Takes the what I want to sample from first, and then the particle values as the UV values as the second one. I want to make the resolution side based on my UV values, so this should look more like a UV map here. Let's make sure we do nearest pixels. Let's do that for both of these. Great. Okay, so now I'm sampling these force values from this field, and I want to add it to my start position. So let's add that. Or sorry, not my start position, my feedback position. And let's drag that in, put that to my to feedback, and then bring that to my feedback loop to close it off. Okay, so now let's also add our reset to our feedback here. Okay, so what's happening here, each of these particles is creating that force field, and then it's sampling from all the overlaps of those fields to then push each other away, so they kind of you get this relaxing effect, right? Okay, so what do we do next? Okay, so next I don't want to just have, right now all the force fields are the exact same size, and what I want to do is instead have the field size based on sampling from some sort of image or texture. So I'm going to just make that from a noise as well. So let's bring in a noise. Let's make this more like 1,000 by 1,000. Okay, bring that into a null, and this is going to be my, what do we want to call this? My sample. And then we're going to bring another input into here. That's where that's going to go. So if I want to change things out, I can just change the input to this null. Let's play with this noise a little bit. Let's make it a little more interesting. So let's create simplex 40 and transform it appstime.seconds over 2. That's maybe a little too fast. Let's go to like 6. Okay, let's make our period a little bigger. Drop the harmonics. I want to have pretty good contrast. Okay, that looks pretty good to me. So, okay, so I brought this into here, and now I want to use this to create the scale for these particles. So to do that, I'm going to also remap this. So I'm going to sample this texture with these UV coordinates. I'm going to bring that into a null called scale. And then let's make sure our values here are correct. So red and green is right, but do I want to change the resolution source to be the UV image? And then this is going to end up just being a mono value. So let's go 32 mono. It's just a straight up scale size from a mono image. And yeah, let's add that into our instancing. Let's see, I know for sure, well, no, let's see. I'm gonna also add a math in here because I know I'm gonna end up changing how this looks. Also, so I can visualize what I'm doing. Well, yeah, so I can visualize what I'm doing. I'm gonna bring this into a limit and normalize it, -1 to 1. I'm gonna hit view, bring down the size a bunch. All right, so if I hit 1, I'm getting my relaxing here. Everything's the same size. But then let's bring in the scale. And now I'm getting the field size changing based on this noise. So okay. So let's see, what can we do now? So getting sort of a jumpiness in there. I think maybe I should bring this texture down a little more. Let's see if we make it a little smoother by bringing the opacity down between the particles. That's feeling a little better already. All right, and then I'm also gonna bring up the scale of my particles a little more as well. So there's kind of more overlap. There's more range that they have when they're the full size. Cool. Okay. Let's bring it up even a little more. There we go. Okay. So when I originally made this, I thought like, okay, this could be a cool way to do like a stippling effect. So let me show you that first, and then I'll show you how the effect that I liked the most that came out of this. So to use this as a basic stippling effect, I'm going to bring this out and put in a new instancing. So bring my to feedback position, or my position feedback. I'm going to bring that out and just make another instancing network here, just with really small circles. And I could also do this as particle sprites, but I'm going to do it as circle constants for now, or circles with constants. So let's see, render. And then this one, I can make this one 1080 by 1920. Have this be my output. And let's make our instancing network. So if I bring in this position, I get all my particles, just my particle information coming across here, right? And this is kind of your type of stippling effect, which is okay. I mean, I think there's some other tutorials out there, like Picada 12 has an amazing tutorial on how to do this with more Voronoi sort of, instead of rendering just these force fields, he's using overlap of cones to make sure that there's no exact overlaps. I think this might be a little more efficient because I'm not calculating collisions with geometry, but I'm also doing all that overlap of layers. So I'm not sure which ones. I think this might be a little more efficient, but also not as smooth looking as that Voronoi pattern that he's getting. So yeah, so you could use this just for a sort of stipple effect, bring in an image, and it'll relax into like the stippled effect. But the effect that I liked to get out of this, I'm gonna bring this render output actually out into a null. I'm gonna hit A and N so I can see these sort of normalized values, and then I'm gonna bring that into a math. And I'm going to rearrange this based on these values. So I'm going to do sort of normalize, but I don't want to actually do a normalize, because normalize will calculate the maximum value every frame, and you get this sort of flashing effect, especially on sort of the gray areas, the backgrounds. But I just want it to be hard set somewhere, so I can kind of look at these numbers and see like, okay, they're getting to around 0.001 maybe is the max. So I'm going to rearrange this from -0.01 to +0.001 to start, to to a -1 to +1. Okay, so now I've got a nice smooth normalized view. Get rid of this one for now. And let's go ahead and put this to an output and view that as we're changing it. Okay, so I mean, this on its own is looking kind of cool. I think turning it black and white makes it more interesting. So if I put in a monochrome, and let's do 32-bit mono. So this, gives us a cool kind of this sort of crocodile skin, goosebump sort of texture. Why is this not letting me disguise it? There we go. Which is amazing, I think. I could take this and I liked putting it into a sharpen. So if I bring it into image filters on my palette, image filters, and then sharpen. So if I bring it in here, then sharpen it up a little bit so I get those nice clean points. From there I can do a lot of things. I could put it in a fit top and decide, okay, this is now I want to start bringing it into my 1080 by 1920 for social, and I want to fit to the outside, maybe move left and right to figure out where I want. And yeah, I mean, I think such a fun effect. You can go in and you can change this noise input to be whatever you want. So maybe I want to, what else could we add to this? So we could add maybe a moving wave ramp or something like that through it. So let's bring the period down on this. Let's mirror it, and let's change the phase. A little faster. So now I get sort of a wave going through it as well. That's a multiply. Let's add. So yeah. Anyway, lots you can play with this. You could put in a camera input to this. You could put text behind it, whatever. But I think it's kind of a fun way to get this amazing reactive particle effect. And yeah, I'd love to see what you make with this. If you have any fun ideas, I definitely would love to see what you make with it. And yeah, I'll leave it at that. Thank you so much for watching. You can get this project file as well as all of my other project files from my tutorials and a few of the tools that I've started making on my Patreon. You can click on the bottom and see that. And that support is super helpful for me. And I love hearing from my Patreon supporters of what sort of tutorials they want to see next, or what questions they might have. I'm more than happy to help out. I respond to everybody that sends me a message there. Thank you so much, and I'll see you at the next one.